In our first two classes, we learned why Kubernetes exists and how we got from single containers to needing something to orchestrate them. Today, we open the machine up and look inside AAnThe 82112, the architecture of a Kubernetes cluster. Now, the promise of Kubernetes is almost magical. You tell it what you want running, and it just keeps it running, healing failures and scaling on its own. Today, you will see the machinery that delivers that magic, and you will find it is beautifully logical. A cluster divides cleanly into two halves, a control plane that thinks and decides, and worker nodes that do the actual running. Understand those two halves and the handful of parts inside each, and the whole of Kubernetes stops being mysterious and starts making sense. So let us look inside the cluster. Here is what we will understand today. First, the two halves every cluster is built from. Second, the API server, the front door to everything. Third, its CD, the cluster's memory. Fourth, the scheduler and the controllers. Fifth, the worker nodes and what runs on them. And sixth, how it all reconciles into that self-healing magic. Let us begin. Let us start with the biggest, most useful division, the one that organizes everything else. On one side is the control plane. This is the brain of the cluster. It does not run your applications itself. Instead, it makes all the decisions, and A212 what should be running, where it should run, and what to do when something goes wrong. It is the management layer, the part that thinks. On the other side are the worker nodes. These are the muscle. They are the machines and AAnThe fall, physical or virtual and AAnThe that actually run your containers, doing the real work of serving your application to users. They carry out what the brain decides. And that split is the whole shape of a cluster. One part thinks and directs, the other part does the work. Almost every component you will meet belongs clearly to one side or the other. So the takeaway, every cluster has two halves and AAnThe, a control plane that decides what should happen, and worker nodes that actually run your applications. Brain and muscle. Let us step into the control plane and meet its most important component, an A212, the one everything else revolves around, the API server. The API server is the front door of the entire cluster. Every single request and 85 all, whether from you typing a command or from another Kubernetes component going about its work, and 85 all, DAWAL or deity, DAWAL, deity 5 all, goes through the API server. Nothing bypasses it. This makes it the one central gateway. You never talk directly to etcd or to a node. You talk to the API server and it coordinates the rest. Every other component too communicates through it, rather than directly with each other. It is the hub of all conversation in the cluster. Why design it this way? Because a single gateway gives you one clean place to enforce security, validate every change, and keep the whole system consistent. All traffic funnels to one well-guarded door. So the takeaway, the API server is the cluster's front door and A212. Every command and every component talks through it, making it the single central gateway for everything that happens. Behind that front door sits the cluster's memory, and it is a component you must respect, an A212 etcd. etcd is the cluster's database. It is the single source of truth, and 8212, the one place that holds a record of everything, every object you have created, every setting, and crucially, the entire desired state, the description of what the cluster is supposed to look like. Everything the control plane knows about the world, it knows because it is written in etcd. When you ask for something to run, that request is ultimately recorded here. When a component needs to know the truth about the cluster, it reads from here to the API server. It is the cluster's persistent memory. And this is why etcd is treated with such care. If you lose etcd, you lose the cluster's entire memory of what it was doing and what it should be doing. Backing it up is one of the most important jobs a cluster administrator has. So the takeaway, etcd is the cluster's database and A212, the single source of truth that stores the entire desired state, which is exactly why protecting it matters so much. The control plane has two more workers that turn stored intentions into real decisions, and A2112, the scheduler and the controllers. The scheduler has one focused job. When a new container needs to run, it decides which worker node it should run on. It weighs up how much spare capacity each node has and any rules you have set and picks the best home for that workload. It is the cluster's placement expert. The controllers do something subtler and, honestly, magical. Each one continuously watches the current reality of the cluster and compares it to the desired state stored in etcd. The moment it spots a gap, an 80-20-12, a container that was supposed to be running, has crashed, say an 80-20-12, it quietly acts to close that gap, bringing reality back in line with the goal. This constant watching and correcting is the beating heart of Kubernetes self-healing. Nobody has to notice the crash and fix it by hand. A controller sees the mismatch and repairs it automatically. So the takeaway? The scheduler decides which node each container runs on, and the controllers constantly watch reality against the goal and quietly fix any gap and A22L, which is where self-healing comes from. Now let us cross over to the other half and look at the worker nodes, where your applications actually live. A worker node is simply a machine, and A212, a server, or a virtual machine in the cloud, and A212, whose job is to run your containers. When your application is serving real users, it is doing so here, on the worker nodes. This is where the actual computing happens. And here is where scaling becomes beautifully simple. Do you need to handle more load, run more copies of your app? You add more worker nodes to the cluster. The control plane immediately sees the new capacity and starts using it. Growing your cluster is largely a matter of adding nodes. It is worth holding the relationship clearly in mind. The worker nodes are the workforce that does the labor, and the control plane is the management that directs them. The nodes are powerful, but they need to be told what to run. So the takeaway, worker nodes are the machines that actually run your containers, and you add more of them to add capacity and AT112. They are the workforce that the control plane directs. For a node to take orders from the control plane and run containers reliably, it needs a few small components of its own. Let us meet them. The first and most important is the kubelet. The kubelet is the node's own agent, ND84 cores. It takes instructions from the control plane, makes sure the assigned containers are actually running, and reports their heads back. It is the control plane's representative on every node. Alongside it is the container runtime, the underlying engine that does the low-level work of actually starting and stopping the containers. The third piece is kubeproxy, which handles networking on the node, and A212 the plumbing that lets your containers find and talk to each other across the cluster, no matter which node they land on. So each node carries this small, consistent trio: the kubelet managing containers, the container runtime running them, and kubeproxy connecting them. Together, they let a node faithfully carry out the control plane's wishes. So the takeaway, every worker node runs a kubelet, a container runtime, and kubeproxy, and AT112 to run its containers, keep them alive, and connect them across the cluster. Now let us watch the two halves work together in a single flow, because this is the loop that makes Kubernetes what it is. It begins with you. You declared the desired state, and A212, you describe in a simple file what you want running, this application, this many copies. You hand that declaration to the API server, and it is recorded in etcd as the goal. The control plane takes over. It stores your wish and makes its decisions. The scheduler picks nodes. The controllers note that these containers should exist but do not yet. Then, it passes the instructions down to the chosen nodes, whose kubelets bring the containers to life. Reality now matches your declaration. And here is the elegant part. It does not stop there. The control plane keeps watching forever, and anytime reality drifts from your declared goal, it acts again to restore it. The loop never ends. So, the takeaway, you declare the desired state, the control plane records it and decides, and the nodes make it real, and A21, then the cluster watches forever, continually reconciling reality back to your wish. Let us lift all of this into the single big idea that defines Kubernetes, the one worth carrying with you everywhere. You tell Kubernetes what you want, in 8212, the end state, the destination. You do not write out the step-by-step instructions to get there. You simply describe how things should look when they are right. This is called declarative control, and it is a profound shift from ordinary scripting. And Kubernetes takes care of the how. It figures out the steps, carries them out across the nodes, and A8202, most importantly, and A8202 keeps working tirelessly to hold reality at your desired state, correcting any drift, healing any failure, indefinitely. That is why running things on Kubernetes feels so robust. You are not babysitting a system and reacting to every problem. You have declared a destination, and a tireless machine keeps driving there and staying there on your behalf. So the takeaway, you declared what you want, and Kubernetes continuously works out how to achieve it and keeps reality matching it, and 8212 declared the destination, and it drives there and stays there. Let us gather the whole class in one breath. A cluster has two halves, and 8081, the control plane decides. The worker nodes run your apps. The API server is the front door. Everything talks to it. etcd is the database, the single source of truth for the whole cluster. The scheduler places containers, and the controllers repair any drift. Each node runs a kubelet, a container runtime, and kube proxy. You declare the desired state, and Kubernetes reconciles reality to match it. Next class, the pod, the smallest thing you can run. One idea at a time. That is the architecture of a Kubernetes cluster, an 85v212, a control plane that thinks, worker nodes that act, and a tireless loop that keeps reality matching your wishes. It can look intimidating from the outside, but inside it is a small, logical set of parts, each with one clear job. Hold this map in your head, and 82112, brain and muscle, declaration and reconciliation, and 82112, and everything you learn from here will slot neatly into place. We will see you in the next class.